Continuing where we left off, let's talk about how hurricanes form. First of all, as I've said in several videos, hurricanes are intense low-pressure systems. And so these are low-pressure cells that break away from near the equatorial region, and they grow in intensity in the following way. I'm going to give you 3 steps, and it's all about water. I have a little diagram over here where I'm trying to show you what happens, and so you might want to sketch this as well. So the first thing is that the surface winds feed water vapor into the storm. And so you've learned about winds previously. And so here's the ocean. Here are the winds. And remember, these are low pressure systems, so air is going to rise. And the winds are going to go upwards. And water is going to evaporate from the ocean and rise up into the air. And remember that evaporation is a process that stores or absorbs energy. That's through something called the latent heat of evaporation. So water vapor, which is a gas, is up here, it's invisible, and it's storing energy. And this is energy that's going to fuel the hurricane. Right now, it's invisible. Step 2 is when that water vapor condenses back to a liquid. Then it's going to release that heat that it absorbed up here. That's from the latent heat of condensation. And when it's condensed, it turns into clouds and rain. Step 3 is basically repeat this sequence of events. Once this latent heat has been released, it's going to cause the atmosphere to warm and rise even more, and it's going to draw more water up into the atmosphere in the form of evaporation. It's going to store and absorb energy, then it's going to condense and release that energy, form clouds, and the storm will intensify. And as long as this system is over warm water, it's going to continue to grow. And that's why I said in the previous video that hurricanes can get very, very powerful in the Pacific Ocean where they are over water for a long time period. The only times when hurricanes tend to diminish is when they move over colder water, because they have no more warm, moist air, or when they move over land because they no longer have any moisture, and also friction with the land slows them down. Here's an example of a hurricane from 1996 called Hurricane Fran over 2 different days. Here are isobars showing an intense low pressure system for the hurricane out over the Atlantic Ocean on a Thursday. 1 day later, the hurricane has definitely diminished in its low pressure intensity. You can see the isobars are farther apart from each other as they were over here. And that's because it hit land and it no longer had its fuel, it no longer had its warm water to keep it going. Here's a recent study that I just read about. So a couple years ago, you might have heard about this really intense hurricane called Hurricane Michael that did $25 billion worth of damage to Florida's Panhandle. So here's Florida in this little map, and then there's the Florida Panhandle right there. And this was a storm that intensified from a Category 2 to a Category 5 in 1 day before it hit landfall. So let me show you some of these symbols on this map. The colors indicate temperature anomaly from normal. So if it's this kind of whitish yellow color, it's normal. If it's in the blues, which nothing is here, it's colder than normal. And if it's in yellow, orange, or red, it's warmer than normal. So everything here is warmer than normal. And here is the path of this hurricane, Hurricane Michael, on October 9, and then 10, 11, somewhere in there is 10. And the symbol, the size and the color indicates when it was a tropical depression, which is not even shown here, tropical storm, Category 1, 2, 3, 4, 5. And there it's a 5 when it hits land. And this is its position. And so they were trying to understand how did it intensify in 1 day? And it's because the ocean water was really warm, unusually warm. These green boundary lines are showing where the water was unusually warm near the coast. It turns out there had been a number of other storms that were smaller in the month ahead of Hurricane Michael. And one of them was Tropical Storm Gordon. So it was a tropical storm and never made it up to hurricane size. But it came in along this path right here a month earlier. And it turned out that what Tropical Storm Gordon had done was stir up the ocean water in the Gulf so that it brought the cold water from deep in the ocean to the surface, and the warm water went down. And this is kind of what these storms do. That cold water reached the surface and then warmed up. And then when Michael came in, when it did its stirring, there was no cold water to bring to the surface. So it was just all warm water. And that just gave incredible amounts of fuel to Hurricane Michael, and thus it intensified. So I'm really simplifying the study, but I'm just showing you that even today we're learning a lot more about how hurricanes intensify and trying to understand how they change when they approach land. And then, of course, this one, as you see, diminished quite rapidly as it moved onto land. Okay, so here's the picture I showed you earlier, the cartoon of the hurricane. And what I'm showing you here is the wind speed, which is in this red color here. And the units for the wind speed are on this axis. And its pressure, which are on this axis, this orange color. And then time along the bottom. It's 3 days. So it was noon to midnight, to noon, to midnight, to noon. So it's 3 days. And it was actually a leap year. What we're seeing is the passing of the eye of the hurricane at this particular station. So you can see that the winds were 20, 30 knots, which is similar to miles per hour. And then they really sped up, and then they dropped almost to 0. And then they sped up again. And the air pressure, which is 1,000 bars, which is about normal, really dropped right down at this point, and then went back up. And so right at this time, at midnight on this cusp between March 1st and 2nd, the eye of the storm actually passed. So that was kind of an interesting proof of what's going on when the eye of the storm passes. I mentioned storm surge earlier. And so one thing that happens from hurricanes is that that low pressure system brings water with it. This is in addition to other things that hurricanes bring. They bring fast winds and they bring flooding from the rains, but the storm surge is actually the most damaging. So here's a little cartoon showing average sea level and normal high tide, and then storm surge can really do damage to coastal buildings. And here's another cartoon showing it as well. You may or may not remember Hurricane Sandy, which hit the East Coast pretty far north in October 2012. And this was a prediction that was made before it actually hit. So here was the hurricane, and this is where they were expecting 5 to 10 feet of storm surge along New Jersey. And then they also had a color coding for other types of flooding that they were expecting. Well, indeed it happened. This is part of the New Jersey coast. And this was just a block or two in from the coast. Here's some other damage that was caused by storm surge. And this to me was the most incredible sight. This guy is digging all this sand out of his living room because storm surge doesn't just bring water, it brings the sand with it. And so the water came into his house, it brought the sand, the water left, and now he has to dig a foot of sand out of his house. Pretty incredible. Another interesting thing about hurricanes hitting the coast is that depending on what side of the eye you're on, you might not get it as bad as the other side. For example, remember these hurricanes are spinning, and then the whole hurricane itself is moving as this white arrow is showing, for example, 50 kilometers an hour towards the coast of the Carolinas. Well, on this side, not only is the hurricane moving towards the Carolinas, the hurricane itself is spinning in that direction. So if you add the movement of the hurricane plus the movement of the fact that it's spinning that way, you're going to get winds coming at you at a total of 225 kilometers an hour. On the other hand, over here, where everything's actually spinning away from the coast, when you combine those, you only get 125 kilometers an hour of things coming at you, and they're actually spinning in the other direction. So, a little fun fact, depending on what side of the eye you're on, you might not have it as bad as the other side. What about forecasting? It's hard to forecast exactly where a hurricane's going to go. Meteorologists give cones of forecasts. So here's the location of the storm. This was in 2007. It was a tropical storm called Tropical Storm Dean. Here was its location at 5 p.m. on a Tuesday. And this is where they predicted it to be at 2 p.m. Wednesday, Thursday, Friday, Saturday, and Sunday. S means tropical storm, H means hurricane. And this was the forecast cone. Now, of course, every day as Tropical Storm Dean moved, they would adjust this cone, but this is the best they can do to say where it's going to be, somewhere in this cone at this time. Now, if it started to go in this direction, then the cone would be adjusted and it would maybe be projected over here. So it's difficult to project where a hurricane is going to go, but they're doing better and better with more and more instruments and more observations. Hurricane Katrina. I couldn't really give you a lecture about hurricanes without mentioning Hurricane Katrina, which was an absolutely incredibly damaging hurricane that hit New Orleans and many other places along the Gulf Coast. This is your typical picture of a hurricane, as it says the traditional image of Hurricane Katrina. Here's the path of Katrina, which came in and kind of just kissed Florida and then went back out into the Gulf, built up some more energy, and then smack dab into New Orleans. Here's the total rainfall when it was a tropical depression, tropical storm, and hurricane. I don't even know if I told you why it's called a tropical depression. It's not because it's sad. It's because it's a low pressure, right? Low pressures are depressed pressure, low pressure. And so this is the storm track that it eventually made. And you can see where the rains were very intense at this point right here. Here we have some of these tall towers that you saw in one of your homeworks that tells them where the storm is intensifying. This was showing the wind speeds, and the colors that are in the purple are showing the more intense wind speeds as it was approaching New Orleans. This is the result of the storm surge after that hurricane passed in New Orleans, and you can see that much of the city is underwater 15 years later, and the city is still recuperating. Coming up next, the world of oceanography.